All right, let's do some conversions now. All right. So a newspaper reported the following measurements in two different stories. The distance from Earth to the Moon is 38,440,300,000 centimeters. Whoa. A worm measures 0.0019 meters. Whoa. Does anything seem strange to you about those two measurements?
Why they would show up to you in centimeters and meters?
Why would you measure the distance from the Earth to the Moon in centimeters?
That's such a big...
That seems like the wrong unit to use, right? What unit would make more sense?
Like kilometers.
Kilometers, right? That's how you measure bigger distances, right? So let's state that as a more appropriate unit. So we would use kilometers for the Earth to the Moon. What about the worm? What unit would make more sense for measuring the length of a worm?
Probably centimeters.
Probably centimeters, right? Use centimeters for the worm. You could maybe also get away with millimeters, but centimeters I think would be appropriate. Alright, cool. So let's actually convert these units. Alright? And to do that, I'm going to give you some hints, and then I'm going to show you a brand new way of converting units, which is like going to be your best friend from now until the end of high school. Very fancy word. Anyways, let's get us some hints here first. How many millimeters are in a centimeter? 1 centimeter.
10.
10, okay. That'll be helpful. How many centimeters in a meter? 100.
Millimeter.
And how many meters in a kilometer? 1,000. Good. So those are going to be helpful conversions for when we try to convert these units to their more appropriate units. So I'm going to teach you something called, ready for this? It's a pretty big fancy word. I don't normally teach it this early, but you know what? It's so universal that I'm going to teach it to you now. Usually teach it in the third section, but dimensional analysis. This is a skill that is brand new to you here in high school, but it is a very, very fantastic skill to have. It allows you to do all sorts of crazy conversions, which would normally be very difficult. You use it a lot in math, you use it a lot in chemistry, and a lot in physics. Okay? Here's how it works. What you do is you take your initial measurement. So I'm going to do it with, I'm going to do the worm first since it's a little less numbers to write. You take your first measurement and you just basically write it. The next thing you do is you ask yourself, what units do I want to convert what I have in? Like what unit do I want to convert into? I have meters and I want to go to what? Centimeters, right? I want to go from meters to centimeters. Do I have a conversion that goes straight from meters to centimeters? Do I have a relationship? Do I know a relationship between those two measurements?
Meters,
Pardon me?
They both have the letter for meters.
No, I mean do I know how many centimeters are in a meter?
Yes.
Yeah, right, we just determined that. There are 100 centimeters in 1 meter, or we could say 100 centimeters equals 1 meter. So what we do is we set up something called a conversion factor, which basically means we take this relationship and write it as a fraction to convert what we have into what we want. Okay, so here's how we do that. I'm going to take 100 centimeters equals 1 meter, turn it into a conversion factor by putting 1 meter on the bottom of my fraction and 100 centimeters on top, and I'm going to multiply that by what I had before. Now, it might seem strange why I'm doing that, but let me just explain the whole idea behind this. Kendall, you're really going to want to pay attention to this. Like, write it down, pay attention to this. You guys remember, well, let me just ask you this. What is 4 over 4, or 4 divided by 4?
1.
1, okay. What is 7 over 7, or 7 divided by 7? Still 1. What if I had like 7 times 1 over 7? What would that be? It'd still be 1, because you would put this over 1 and you multiply the tops and you get 7 over 7, and you still have 1. Right? Essentially what I'm saying is, when you have something on the top of a fraction and something on the bottom of a fraction, those two things cancel each other or divide each other to create a 1. And when you multiply something by 1, it doesn't change what you have. Right? So that's why we call it canceling, because it essentially just disappears inside of your multiplication. You can do the same thing with units of measurement. Okay? So in this case here, you'll notice that if we put this 0.0019 over 1, we have a meter unit up top and a meter unit down below. And just like I said before, when you have something on the top that's the same as something on the bottom, those two things can cancel one another. Follow the line of thinking there? Okay? So those dimensions get canceled because there's one on top and one on the bottom. And what you're left with is centimeters. Now to get your measurement in centimeters, all you have to do is multiply all your numbers on top. So in this case, 0.0019 times 100. Multiply everything on the bottom, which are, in our case is just 1 times 1. It's not, and it's going to be 1, so we can just kind of ignore that. And then divide the two amounts. Right? So 0.0019 times 100 is... Just move that decimal 2 places to the right.
So
0.19, and if we divide that by 1, that doesn't change anything, so it's just 0.19. This measurement is in centimeters, because that's what we just determined. That's what we ended up with after we did some cancellation. Okay? And I know it might seem a little strange to do it this way, because all we did really was multiply 0.0019 by 100. It's a lot easier to say that, right? But in showing you this way, I'm trying to prepare you for a skill that's going to be really, really useful. That's going to be very versatile, and it's going to allow you to do a lot more complex things than just something simple like this. But this, sorry, just let me finish. But this skill is very universal in that you can use it for something just as simple as this, as well as something very complex, like converting something in feet per second to kilometers per hour, which is quite difficult unless you use dimensional analysis.
So, when timesing like the decimal number by like something like 100, you take the number of zeros, and that's how many times you move the decimal point over?
To the right, yeah. Yeah. When you multiply it by powers of 10. Right. All right, let's do the other guy now. It's got a few more numbers, but we should have a better idea of how to convert. So let's take, somebody read that number to me, 38 billion.
38,440,300,000.
300,000, and that was centimeters, right?
Yeah.
And using dimensional analysis, we want to go from centimeters to what?
Probably
Kilometers, right?
That's gonna be a lot.
Do we know a numerical relationship between centimeters and kilometers? Like how many centimeters in 1 kilometer? Do we know that?
No.
No, like
We know
we could
centimeters.
figure it out.
You know centimeters and meters, then meters to kilometers.
Yeah, so let's do that. Let's go, instead of directly centimeters to kilometers, we're going to take a detour and go to meters first and then kilometers. Follow that? Okay, so let's do that. So again, dimensional analysis, I always start by just writing the very first measurements, and it's usually helpful to put it over 1 because we're going to be multiplying fractions in a moment. My first conversion should take us from centimeters to meters. What was the relationship between those two again?
Centimeters. There's 100 centimeters in a meter.
There's 100 centimeters in 1 meter. I write that as a conversion fraction. Sorry, a conversion factor. So I create a fraction, and I want to make sure when I write my fraction that centimeters gets canceled. So where would I put 100 centimeters in my fraction to make sure that it got canceled?
On the bottom, on the right.
On the bottom. Why the bottom? Why not write 100 centimeters up top?
Because
It won't cancel.
It won't cancel, right? To cancel the centimeters, I need a centimeter on the top and a centimeter on the bottom. right? So you can write this fraction either way. You can write with 100 centimeters on top or 100 centimeters on the bottom. But make sure you write it so that your unit that you want to cancel actually gets canceled, right? So 100 centimeters goes on the bottom. That will cancel what we have before. And then the meter, the 1 meter, goes up top. Okay, and let's just make sure that the cancellation actually works. Centimeter up top, centimeter down below. Things do cancel. Follow? So now my units are in meters. Am I done? No, because I want to go now from meters to what?
Kilometers.
To kilometers, right? Do I have a relationship between kilometers and meters?
There's 1,000 meters.
Yeah.
in a kilometer.
There's 1,000 meters in a kilometer. Okay, so 1,000 meters is 1 kilometer. Let's turn that into a fraction. Where am I going to put the 1,000 meters? On the top or the bottom? Yeah, you guys got it. See, isn't this simple? Say yes.
Yes.
Now my meters cancel because I have a meters on the top and a meters on the bottom. And I end up with, in the end, kilometers. And now the final step, I take all the numbers up top, multiply them, all the numbers down below, multiply them, and divide. So that gives me 38,440,000, 300,000. I could put the times 1 times 1, but when you multiply something by 1, it doesn't change it, right? So I don't need to put those. That's just extra writing. You can ignore the ones. All over, what am I multiplying on the bottom? 1,000 and 100. And a 1, but that doesn't matter. So there's 100 times 1,000. So, what does that give me?
So it's divided or multiplied from the 30.
So multiply these first together, and then take your top and divide by what you got. If it helps, you can just rewrite it. What is 100 times 1,000?
100,000.
100,000, right? So now do that, turn that, or divide that fraction now. The top divided by the bottom. What do you get?
384,403.
Yeah. And what are my units? Kilometers, right? We just converted it into kilometers. Thanks, dimensional analysis. You're the best.